you backing Bob into that corner for? You gonna give him the third degree?
Not quite, Tech. I kind of figure that Bob needs something in the way of an advanced degree.
Advanced degree? Say, I'll go for that. I'll do anything to get ahead of my job.
Now, don't sound so anxious, Bob. Let's listen to Tom's proposition first.
I can see you fellas aren't going to be easy to convince. What I had in mind is a review of the Powerflite transmission and power steering units.
A review? What for? We're not having any trouble servicing those units.
I know, but many changes have been made during the past year or so. Some are design changes, and others affect service. So it seems like a good idea to review them and bring everybody up to date.
Well, Tom, now you're talking. I guess Bob and I'd better go over those improvements with you. We can all benefit.
I agree, Tech. And that's a horse of another color.
All right, suppose we take up the Powerflite changes first. I've collected some of the parts we'll be talking about, like this front pump housing dust seal, for instance.
The dust seal?
Yeah, Bob, this seal not only keeps dust and foreign matter out of the front pump cavity, it also keeps oil in.
Oh, then it's also an oil seal.
It has to be. Some oil normally gets into the pump cavity, but the front pump housing has a drain-back passage. So oil that does get there can drain back to the transmission case.
Here's something you want to keep in mind, Bob. If you spot an oil leak at the front end, don't simply replace the dust seal.
Tech's right. Oil leakage past the dust seal might be due to a seal ring leak at some other part of the transmission.
In that case, where should I check if the dust seal's not to blame?
Well, scratches in the torque converter hub might cause oil to get past the seal, or there might be too much runout at the hub. Hub runout shouldn't exceed 4 thousandths. To correct excessive runout, use a torch to apply heat to the front side of the torque converter. Then quench quickly with wet rags to shrink the hub back in line.
There might be a worn or broken front pump drive sleeve seal ring. This ring seals against leaks between the converter hub's inner surface and the sleeve.
Incidentally, this seal ring has been changed to an O-ring. If you use the new O-ring for replacement, be sure to remove any burrs on the hub. In addition, install the new sleeve also, because it has a wider groove to accommodate the new O-ring.
Okay, Tom. That's pretty clear.
Say, here's that drain back passage in the pump housing that Tom mentioned. Make sure it's open and not plugged up.
Good advice, Tech. That quarter-inch hole should be drilled completely through the housing and open all the way. Now, here's another item. Early production transmissions had an input shaft with 3 steel seal rings. These sealed against the inside diameter of the reaction shaft to prevent leaks. Check these rings for wear or breakage.
Suppose I find a worn or broken input shaft seal ring.
You can still get new ones for replacement, but the input shaft now being used doesn't have the 3 seal rings. Instead, a large area bushing pressed in the reaction shaft supports the input shaft. This bushing arrangement provides a better bearing support, but you can't service this bushing separately. It's supplied only as a part of the new reaction shaft. So, if you want to install this new input shaft as a replacement for the early production shaft, you'll have to install a new reaction shaft, too.
That makes sense, Tom. Now, what else have you got on the transmission?
A new regulator valve body with a new torque converter control valve. You'll remember the control valve used to be in the passage leading to the converter. In the new valve setup, the control valve is in the passage from the converter. At this location, it controls pressure within the converter, which makes it more efficient, and it prevents the loss of transmission fluid out the filler tube under extreme operating conditions. Incidentally, the new control valve uses a spring with less tension.
Yeah, Bob, and that valve spring is not interchangeable with the earlier type. Here's something else. If you're not careful, you might install the control valve incorrectly. Install it with the hole facing away from the regulator valve body.
Good point, Tech. If that installation's made wrong, you won't be able to remove the valve from the regulator body without first removing the transmission and front oil pump body assembly.
Wow. I'll remember to get that valve in right.
Fine. Now, you can install a new valve body in early production units, but you must install the new control valve in it. Besides that, you'll have to remove the converter outlet valve assembly from the oil line outlet passage on the left side of the case. If you don't, it'll prevent proper lubrication of the transmission.
You don't need that outlet valve with this new control valve, Bob, so throw it away.
That's the idea. Now let's talk about the new three-stage governor. It's used on transmissions being built right now, and it provides much closer control of the shift speeds. In addition, this new governor limits the wide-open throttle upshift to a more uniform speed. It also provides a more uniform high-speed kickdown limit.
Sounds like a lot of good advantages.
They sure are, Bob. The three-stage governor has three weights: the outer, intermediate, and the inner. The two-stage governor had only an inner and an outer weight. The three-stage governor as a complete assembly can be used to replace the two-stage governor, but you'll also have to replace the governor body support.
Yeah, Bob, but here's something else to remember. There are two sizes of three-stage governors. One goes in six-cylinder cars, the other goes in eight-cylinder jobs.
Glad you mentioned that, Tech. Bob can find the right part numbers for both governors in this reference book.
That's a good thing to know. I'll sure look up part numbers when I replace a governor. What's next?
Well, the 1955 transmission didn't have the reverse blocker valve, but all cars with push-button control do have the blocker valve. It prevents shifting into reverse at speeds above 10 to 15 miles an hour.
And that's a mighty good safety device, Bob. For instance, if an owner accidentally pushes the reverse button when going around 10 to 15 miles an hour, the manual valve simply moves to neutral and no damage is done.
I've heard about the safety job that blocker valve does, but I'm still in the dark about what makes it work.
It's actuated by governor pressure, Bob. For example, if the governor valve sticks, it would cause the blocker valve to remain in the blocked position due to residual governor pressure in neutral. In other words, it would be impossible for the manual shift lever to move into reverse. You'd have a lack of reverse condition.
But before we can tell you what to do about a lack of reverse condition, somebody please turn the record.
We were talking about an occasional lack of reverse condition, Tom, and how I might have to check for the cause.
Right, Bob. Here are the checks you'd have to make if that should ever come up. First, with the engine running, try to shift the transmission into reverse by pushing in the R button. If the transmission will not shift to reverse, either the governor valve is sticking or there is a line pressure leak in the valve body, admitting pressure to the governor circuit. If you have this condition, remove the governor pressure takeoff plug. Then blow short blasts of clean, compressed air into the circuit while you tap on the parking brake drum. Usually this will free up the governor valve. If it doesn't, you'll have to remove the governor and clean it.
If the R button won't go in, regardless of whether the engine is running or not, it means the blocker valve is sticking.
Yeah, and in that case, Bob, you'll have to remove the valve body. Then take out the blocker valve and very lightly smooth down the valve surface. Use a new valve spring, too, when you reinstall the blocker valve.
That clears up the blocker valve for me, Tom. Got something else on the transmission?
Not on the transmission, Bob, but we've got some items on the torque converter. As you probably know, the torque converter occasionally might cause logy performance, poor fuel economy, or excessive transmission fluid temperatures at high speed.
You mean you'd check the converter for all that?
Well, only if everything else checked out first. Here's why. A frozen stator, for example, will raise the fluid temperature much higher than normal. As a result, the seal at the torque converter hub may harden and fail. If you find a seal in this condition, you'd suspect high temperature caused by a frozen stator.
Then we'd have to replace the converter.
Yeah, Bob, but you can check the converter on the car to be sure the stator is frozen. That calls for a couple of special tools, eh, Tom?
Right. Let's take a minute to describe those tools. Here's one I made from an old engine oil dipstick. One end's bent U-shaped, the other L-shaped. A Plymouth high drive reaction shaft is the other tool. You can use both tools to check the 3 and the 4-element torque converters. Look, I'll show you how to do it. This 3-element converter, remember, has a single stator. Check it by inserting the U-shaped end of the tool into one of the 4 rectangular oil passages in the rear face of the stator. Next, you insert the high drive reaction shaft into the torque converter hub. Hold the tool stationary and rotate the reaction shaft. It should move freely clockwise. If it doesn't, the stator is seized and you'll have to replace the converter. When you move the reaction shaft counterclockwise, it should carry the tool in the stator along with it.
When checking the 4-element converter, remember that it's got 2 stator units. You check the rear stator like you check the one on the 3-element converter.
I see. How about the front stator?
You check it this way. Install the reaction shaft, then install the L-shaped end of the tool through the reaction shaft and into one of the oil passages in the face of the front stator.
You won't be able to see those passages, Bob, so just probe around with the tool until you locate one of them.
Will do, Tech. And I'll be careful.
Swell, Bob. Now, like before, the reaction shaft should rotate freely clockwise. When rotated counterclockwise, it should carry the tool.
I see. If it won't move freely clockwise, I'll have to replace the converter, huh?
That's right, Bob. You see, we have no way of repairing it. So the only thing we can do is to replace the complete unit. That about takes care of what's new and coming our way on transmissions. Now you won't get into any arguments with our parts department if they hand you something that looks different.
I see what you mean. And it clears up a lot of questions in advance that I might worry about. You did say something about power steering, though. We're going to cover that?
You bet. For instance, if you get a unit that needs new piston rings installed, this is on cars using steering gears with the steel backing ring behind the synthetic rubber ring, there's a new piston ring package available. This package contains 2 D-shaped rings and 2 ring retainers. For proper piston ring support and tension, be sure the retainers are installed inboard toward the center of the piston.
How about the L-shaped ring?
I knew you'd ask that. Just don't use those L-shaped rings anymore.
Tech's right. Forget you ever knew they were around. And on later model cars, the ring retainer has also been eliminated. So don't install retainers if they were not in place to begin with.
Okay, fellas, I'll watch it.
Fine. Now, changes have been made in the pump pressure hoses. If you ever need to replace them, be sure to use the right ones.
Check the reference book, Bob. It's got the whole story complete with new part numbers.
Okay, I'll study up on the book.
Swell, Bob. Another steering gear item that's new is the lower piston rod relief valve. You probably remember that the relief valve was always secured with a drive-fit end plug. In some cases also, the end plug was pressed too far into the hole. This applied too much pressure to the valve body. A new one-piece valve body, which is a press fit in the piston rod, is now being used. A pin driven through the valve body serves as the plunger and spring retainer.
If you ever have to service that valve, use a bolt as a puller to pull the valve body out of the piston rod. Then use a small drift to knock out the pin.
Okay, Tech, I see how it's done.
Fine. Now, there's a redesigned valve operating rod adjusting disc. A nylon insert nut is now being built into the disc, so it holds the adjustment more securely. In addition, the disc retainer is now made as a part of the disc assembly.
Oh, yeah, I can see how that would help.
That's the only change, Bob. You still follow the same manual control valve adjusting procedure you've been using right along.
Okay. Now, what else is new in the way of a power steering change?
The units being produced now have a new worm thrust bearing and lock nut arrangement.
Are you referring to the 2 tapered roller bearings with inner and outer cups?
Yeah, that bearing arrangement consists of 2 small diameter roller thrust bearings, 4 bearing races, a radial roller worm bearing, and 2 thrust bearing spacers. The spacer containing the radial roller bearing is installed against the lower shoulder of the upper housing. The races are used above and below each roller thrust bearing. The new lock nut arrangement is a combination lock nut and washer deal. The flange extending above the nut is used as a means to lock the nut securely to the worm shaft.
That shaft has a keyway into which the lock nut flange is staked. It provides a much more positive bearing adjustment.
Good deal. I'm glad to get this information on changes. It'll help when I get one of these jobs.
You can say that again, my boy. We know when you have advanced information, you're bound to do a better job. That, in turn, brings other benefits. Our reputation for outstanding service will get around. We'll attract more new car buyers, and that's how we get our bread and butter.